So right now at this stage, you have learned about arithmetic sequences, which is when you add a common difference over and over to create a pattern in a sequence of numbers. And those numbers are separated by commas. And you've learned about a geometric sequence, which is when you multiply by some amount of numbers over and over again to get a pattern in a sequence. And then if you add those terms together in the sequence, you get an arithmetic series. So adding 2, 4, 6, 8 to each other, that becomes a series, an arithmetic series, or a geometric series if the pattern happens to be geometric with the common ratio. And so then you would add those together, and that would be a geometric series. Now, the series you have dealt with so far have been finite, so they have had an ending. They've asked you to find the sum of the first 100 terms or the first 25 terms. So today we're going to talk about infinite series, and specifically an infinite geometric series. So if you look at these two formulas, again, you will be provided with a formula sheet for the test and for any major quiz that will be given. So don't worry about memorizing them. But you do have to know what G sub 1 stands for, what R stands for. So notice here we have the S sub infinity sign. So that's the sum of an infinite amount of terms. And you might be asking yourself, well, how can I find the sum of an infinite amount of terms? That's a good question. Well, you can only find the sum of something with an infinite amount of terms if it's a convergent series. So it has to be approaching. What does converging mean? It means it's moving toward some specific number. And so then if it's approaching 0 or approaching 3, then the numbers are so small, it's like an exponential sequence, right? Or exponential graph. Think of how it approaches an asymptote. It gets really, really close. Well, the difference between the number, the y value, and the y value, two y values really close together is going to be very, very small. So when it's very, very small, if you're adding up 0.00000001 plus 0.00001, it's not really making a big difference to the total sum. Okay, again, if you don't understand what this means, it's approaching a specific number, then ask me in class and I can explain it to you maybe better in person and show you some examples. But in this formula, the sum of an infinite amount of terms equals the first term. Remember, G sub 1 represents the first term, divided by 1 minus the ratio, the common ratio. It's convergent only if the absolute value of the common ratio is less than 1. So what does that mean? That means it has to be a fraction between -1 and 1. That's what this means right here. The ratio needs to be a fraction between -1 and 1. Okay, if it's a common ratio greater than 1, then it's a divergent series. It does not approach a specific number, therefore you cannot find the sum of that series. It's not possible. An example is like 1 plus 2 plus 4 plus 8 plus 16. I'm multiplying by 2 over and over. If I put that as a dot, dot, dot at the end, I'm indicating here, this is what lets you know that it's an infinite series. Okay, it's an infinite geometric series because I'm multiplying by 2 over and over again. And so why is that diverging? Well, it's getting bigger and bigger and bigger. It's doubling in size. And those numbers are approaching infinity. And you cannot add infinity to infinity. They just go on infinitely, so you can't actually calculate an exact sum of that series. The sum would be infinity. However, if you have something smaller, like 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, well, notice my common ratio here is 1/2. So this is an example where the common ratio, the absolute value, is less than 1. And as you add these numbers together, it's going to approach a specific number because these numbers are approaching 0, 1/64, 1 over 1/28, 1 over 500, or 256, 1 over 512. Those are getting so close to 0 that eventually we can just add up the first couple of numbers, and that's about the sum of the entire series. Again, ask me about it in class if you're not understanding. All right, so let's apply what we know with these two formulas. It says state whether or not each geometric series is convergent. If it is convergent, then find its sum. So really, you're just going to find the common ratio in order to determine if it's convergent or not. So we know it's geometric because it tells me right here. So I'm going to find the common ratio. How do I find the common ratio? You take the second term and divide it by the first term. Right? You should have done that enough by now that you know how to get the common ratio. So I take the second term, which is -6, I divide it by the first term, which is 8. So my common ratio is -3/4. Because that absolute value of -3/4 is less than 1, then I know that this series is convergent. The absolute value is less than 1, right? The absolute value of -3/4 is less than 1. Therefore, the series is convergent. Which means, therefore, I can find the sum. How do I find the sum? I use this formula. G sub 1, which is 8. So the sum of the infinite series equals G sub 1 divided by 1 minus the common ratio. Now, notice I don't put in the absolute value here. I actually put in the sum that was given. So it's 1 minus -3/4. So 8 divided by 1 3/4, because that changes to adding a positive. So now just get out your calculator. It's going to be easier maybe to do 8 divided by 1.75, and I get approximately 4.57, etc. So this is a decimal, but that means it's approaching about 4.6. It's getting really, really close to the sum of 4.6, or 4.57. 58, I should say. So here you have it. All right, moving on to the next one. The first thing we would do is find the common ratio. So I take the second term and divide it by the first term. So dividing by 2/1 is the same as multiplying by its reciprocal. Right, so I'm going to take this, turn it upside down. So -8/3 times 1/2. The 2 goes into the 8 4 times, or you can be using your calculator to do this. So my common ratio is -4/3. Well, you should notice that the absolute value of -4/3 is greater than 1. Therefore, this series diverges. So can I get a sum if it diverges? No. So maybe translate these numbers into decimals and see what's happening. What is happening? They're going from positive to negative, positive to negative, positive to negative. But they're jumping back and forth too much, and these numbers are not approaching a specific number. We're going from positive, it's getting bigger, negative, bigger, positive, big, negative. So it's not a specific value. Therefore, we could never find the sum of it if it was infinite. Finally, our last one, we would first find the common ratio. So I'm going to take 4/25 and divide it by 2/5. But remember, so I took the second term divided by the first term to get the common ratio. But when I divide fractions by each other, I multiply by the reciprocal. So here we have it. I guess this isn't the last one. I go 2 into 4, 5 into 25. So it looks like my common ratio is 2/5. Again, this absolute value of 2/5 is less than 1, so it is a convergent series. So the sum of the infinite amount of terms equals the first term divided by 1 minus the common ratio. Oh, they just happen to be the same. Interesting. No big deal, just a coincidence. So that's 2/5 divided by 3/5. Remember, I would multiply by its reciprocal, which is 5/3. So the sum of this series is approximately 2/3. So if you added all these numbers together, they're getting closer. The sum is approaching 2/3, which means this value right here is approaching 0. And finally, number 4, we take the second term, divided by the first term. We divide by 3, it's the same as multiplying by 1/3. 3 goes into 9 3 times. Once again, we have the absolute value is greater than 1. Therefore, this series diverges and I cannot find a sum. Okay, that's the end. I'll see you in class.